Consider a point object moving in the right direction, that is the direction OX. Let's assume that it is performing a uniformly accelerated motion, that is its acceleration is constant. Let's say it is at position A at a certain instant of time t1 and at position B at another instant of time t2. Let's say its velocity at position A is v1 and its velocity at position B is v2. Now I am not writing dash on the top of the heads of the v1 and v2. Why? Because I am taking right direction as a positive one and the left direction is the negative one. So the direction of the vector is incorporated in the sign only. Now let's say the coordinate of position A is x1 and that of B is x2. Now what is the displacement? In time interval t2 minus t1, it will be x2 minus x1 times some velocity into t2 minus t1, that is the time interval. Now what velocity to consider over here? The velocity to be considered over here is average velocity, because this motion is non-uniform motion and to assess it we have to use average velocity. So what is this average velocity? It will be v1 plus v2 divided by 2 into t2 minus t1. This is equal to x2 minus x1. Now in previous to previous video we have seen v is equal to u plus at, where v is the final velocity, u is the initial velocity, a is acceleration and t is the time interval taken to reach from velocity u to velocity v. Now I want to substitute for this, that is, let's say v1 v2 is my final velocity, v1 is initial plus acceleration into t2 minus t1. Now I will substitute v2 minus v1 by a for t2 minus t1, because t2 minus t1 is v2 minus v1 upon a. I can substitute over here. So this becomes x2 minus x1 v1 plus v2 divided by 2 into v2 minus v1 divided by a. Now this becomes v2 square minus v1 square, because a minus b into a plus b will be a square minus b square, divided by 2a. And let's say x2 minus x1 is s, that is the displacement. So this becomes 2as is equal to v2 square minus v1 square, where v2 square then becomes v1 square plus 2as. This is the formula. And if v2 square is v square, that is the final velocity is v and initial velocity is u, then it becomes v square plus u square plus v square is equal to u square plus 2as. We have proved this. Now let's see its graphical proof. Let's say this is y-axis and this is x-axis, that is the axis of time t dash, and this is axis of v dash. Let's say, let me use a different color here. Let's say it has a velocity u when an instance of time t dash is equal to 0, and let's say at another instant of time it has velocity v and it is moving with a constant acceleration. So the graph will be a straight line, and t dash is equal to t, and at t dash is equal to t its velocity is v. Now we can say that the area of this trapezium is nothing but the displacement, because it is the area under curve. So the displacement will become S is equal to area of this trapezium, which is half times summation of the parallel sides, that is this one and this one. This will be u plus v. in, into t, where t is height. So this becomes half. Now I can substitute for t by v is equal to u plus at, we know. So we can substitute for t v minus u by a. So this will be v minus u by a. Now again, this becomes half u plus v into v minus u will be v square minus u square, because a minus b into a plus b is a square minus b square, divided by a, and this becomes, so this is 2as is equal to v square minus u square, then v square becomes u square plus 2as. We have derived it graphically. Now let's look at a proof using calculus method. We know that the velocity at any instant of time is dx dash by dt dash. Now we also know this relation, v dash is equal to u, v dash is some final velocity, u is the initial velocity, plus a times t. Now if I take a derivative with respect to time, then this becomes, this is constant, so this will be 0, this will be a. So it is nothing but the acceleration, the constant acceleration with which the object is performing the motion. Now it will be with respect to t dash, it is t dash over here. Now I can substitute for dt dash is dv dash by a. So I can substitute for dt dash over here in this equation. So let me do this. So this becomes v dash is equal to dx dash divided by dt dash, which is dv dash by a. A will go up, so this becomes like this. Now v dash dv dash will be equal to a dx dash. Now let's integrate. Let's put the limits. U is the initial velocity, v is the final velocity, x0 is the initial position, and x is the final position. So this becomes v minus u, sorry, this will be v dash square by 2, and the limits v and u, this will be a into x dash, sorry, this will be x and x0. Now v square by 2 minus u square by 2 is equal to a into x minus x0, and x minus x0 is our displacement, so this will be a into s, and this is v square minus u square upon 2. So this becomes v square minus u square is equal to 2as, that is nothing but this equals u square plus 2as.